Welcome back. In this session of MOOC on information security, we will discuss protection versus security. Protection. Protection in information security is the method of securing the information by diminishing information risks. This procedure is generally carried out by preventing or even by reducing the risk factors, unauthorized access of data and modification of data. In order to ensure information security, a balanced protection of confidentiality, integrity and availability of data must be ensured. Protection in information security is attained by structured risk management, and it is carried out by the following steps. Identify the information that is to be secured along with the vulnerabilities and impacts of the attacks that can happen. Risks that are encountered should be evaluated. By selecting or by designing security controls, weaken the risk. Monitor the information continuously and make necessary adjustments. Security. Security in networking is based on cryptography, the science of transforming information to make immune to attack. These aspects are confidentiality, integrity, authentication and non-repudiation. There are 4 security services provided by network security that directly deals with the message exchanged using the network, and they are message confidentiality, integrity, authentication and non-repudiation, and another security service is entity authentication and identification. Message confidentiality. The message confidentiality can be attained by encrypting the message at the sender side and decrypting at the receiver side. There are different privacy techniques that ensure message confidentiality. A good privacy technique guarantees to some extent that a potential intruder cannot understand the contents of the message. Message confidentiality is attained by symmetric key cryptography and asymmetric key cryptography. Symmetric key cryptography in message confidentiality. Symmetric key is a technique where same key is used for encryption and decryption. Encryption is a process of encoding information into a coded format, and decryption is a process of decoding, and this technique works only if the key exchange is done properly. This method includes the encryption of the message at the sender side and decryption of the message at the receiver side by making use of same key. In order to solve the key exchange problems in symmetric key cryptography, session keys were introduced. Session key is one that is used only for the duration of one session, and this session key was exchanged between sender and receiver through asymmetric key cryptography. Even though symmetric key cryptography is having many disadvantages, this method seems to be still the dominant method for confidentiality of the message is its efficiency. Asymmetric key cryptography in message confidentiality. In this method, encryption and decryption are carried out by different keys, and so there is no need of any key sharing. In this procedure, sender and receiver of a communication will create 2 keys, one private and one public key. Out of these 2 keys, public key will be announced to the public and the other one will be kept safe. Here, the public key is used only for encryption and the private key is used only for decryption. In other words, public key locks the message and private key unlocks it. Asymmetric key method is considered as a better method, but it is inefficient for long messages as it needs long mathematical calculations. Message integrity. Even though encryption and decryption can guarantee security to an extent, but the integrity of information cannot be ensured. If the information that is sent from the sender side is changed by a third person other than the expected receiver, then a data breach happens. The main reason behind maintaining integrity is to make sure that a data will stay undamaged till it reaches its destination. Message integrity can be achieved by message digest. It is generated from the message that is sent from the sender side with the help of certain function. From the sender side, one hash function is performed by giving the message as input, and the output of hash function is called as digest. This digest is sent along with the message to the receiver. Receiver side will perform the same hash function, and if it gets the same digest, that means the message is not corrupted or integrity is maintained. Hash algorithm SHA. One of the most common hash algorithm is secure hash algorithm SHA, which was developed by National Institute of Standards and Technology NIST. The most common version of secure hash algorithm is SHA-1. There are 3 different criteria which should be followed in order to make the message compatible to create hash. They are strong collision resistance, one-wayness and weak collision resistance. In case of weak collision resistance, it ensures that once the digest is created from the message and the digest and the message is sent to the receiver should not be able to create a different message that hashes exactly the same hash. Strong collision resistance works exactly the opposite, as the sender cannot create the same hash with 2 different messages. Consider the sender system A creates a digest with the message M1 and the system A creates same digest for another message M2. This is not possible because this can lead to repudiation, as the sender can claim that M1 was not sent by him. Third criterion is one-wayness, as the digest is developed by one-way function and no one else should be able to recreate the message from the digest, as we cannot create a document from the fingerprint. In case of SHA-1 algorithm, the message is divided into different blocks of 512 bits and digests are created for different blocks separately. Message authentication. Whenever the integrity is maintained during the digital communication, it can guarantee that the message was not altered in the middle of communication. But this process does not make sure that the message came from the intended sender. The process to make sure that the message came from the right person is called message authentication. Such proof cannot be made by mere use of hash functions. To provide message authentication, a keyed hash function can be made, and it is called as message authentication code (MAC). This method makes use of symmetric key between sender and receiver. Today, MAC is implemented in different ways like keyless hash such as SHA-1. Normally, when we use MAC, the message and the symmetric key are fed into the keyed hash algorithm as inputs and generate MAC as output. This generated MAC is appended with the message and it will be sent to the receiver. The sender device will perform the same keyed hash algorithm and check whether it receives the same MAC. As the whole process works with the assumption that the symmetric key is shared with the intended user for authentication can be guaranteed. Digital signature. Generating MAC to ensure the authentication is not a perfect method to ensure user authentication. Hence, a new method was introduced called digital signature, which acts like conventional signature. In digital signature, it makes use of a pair of asymmetric key, one public and another private. As a pair of keys is present, public key is announced to the whole network and the private one will be kept with the person himself. There are ways by which the conventional and digital signature differ. Digital signature is not included inside a document. Instead, these signatures are kept as a document along with message which is to be signed. Verification of digital signature is also different, as every time when the receiver gets a message, a verification technique must be applied to verify authenticity. In case of conventional signatures, there is a one-to-many relationship between the signature and the documents, as same person make use of the same sign to authenticate different documents, but in case of digital signatures, each document will generate different signatures with the information of the author. Entity authentication. Entity authentication is commonly used in secure payment and cash withdrawal systems like ATMs, where each time the user has to authenticate with some information. Entity can be a person, process, a client, or even a server. Entity authentication can be done in different ways, like by making use of passwords or even by challenge response method. When we make use of passwords, there are certain possible attacks that can be carried out. Eavesdropping. When the user fixes a password for identification, this can be taken by the third person either by listening or by watching client typing the password. File access. Intruder can attack any file in the system which contains password. Either the attacker can take the password and later log in with those credentials, or change the password and take the whole control. Guessing. This is the most common method that is used, where pure guessing can lead to the reveal of the password, and this is the reason why every site asks us to create strong passwords. Challenge response method is another method for entity authentication, and here a challenge will be provided to the client without revealing the password, but claims that he or she knows the password, and later a challenge input will be provided by the verifier. With this input, client uses the function and shows back the result, and if the result is fine, client will be verified and access is provided. Comparison between security and protection. When we consider the terms security and protection, they sound so similar, but there are many differences between them in various aspects. First of all, the major difference is that security deals with the external information threats and protection deals with the threats that can happen to the internal issues. By providing security to the information means the information can be accessed by legitimate users only, whereas the term protection can control the access by any type of user. Security deals with more complex issues, but protection deals with some of the simple queries. Policies that are used in these areas are also different, like security describes which person is allowed to use the system, but the protection will specify what all files can be accessed by a particular user. In protection mechanism, authorization is used and security mechanism will authenticate each user and encrypt the user or process so that it can enforce the integrity. Security in terms of information can also be called as risk management, but security doesn't mean to eliminate all threats, but it deals with elimination of already known threats and minimizing the loss even if the attacker succeeds in attacking. Risks are identified and then classified into different categories like extreme risk, where immediate actions are required, and other categories are high risk, moderate risk, and low risk types. Actions will be taken according to the severity of the risk encountered. Security controls can be preventive, and sometimes these controls can be detective or even responsive. Preventive actions can be taken in order to act before the risk appears, and some controls can be used to detect the risk and act according to it. Responsive actions are taken in response to the risk already faced during the communication. These security goals can be called as CIA: confidentiality, integrity, and availability. And so, each information security professionals who develop the procedures and policies to secure the computer system should consider all three goals. Now, let us summarize this session. Information protection includes security solutions, encryption and other technologies as well as many other policies and processes to secure information. Information protection can be considered as the component of information assurance. Information assurance mainly focuses on ensuring quality, reliability and accessibility of information in addition to keeping it protected, but information protection is focused on achieving this through information security. While implementing the information protection and assurance in an organization should follow some assessment methodology which includes identification, authentication, session controls, configuration management, virus protection, etc. This is achieved by taking precautions against unauthorized destruction or alteration of information and ensuring the non-repudiation and authenticity of data. Hence, the concept of protection and security are discussed in detail in this session. A comparison is also given to clearly identify the differences between protection and security. Hope you enjoyed this session. See you next time. Bye.